The story of electricity at your fingertips starts hundreds of miles away where it is generated. A power distribution company transports and distributes this electricity to the consumers using an intricate network of overhead lines and transformers. However, like any other distribution, this system is also not leak-proof. We have made peace with the fact that some electricity and also some revenues will be lost in transmission and distribution. These are the AT&C losses, or aggregate technical and commercial losses. Did you know that of 24% national average AT&C losses, at least 3 to 4% come from technical losses in DTs or distribution transformers? In India, these 24% AT&C losses in 2015 stood at 3.6 lakh crore. That's huge. Also, these DTs account for a whopping 12 to 15% failure rate in India, which is nearly 15 times of that in developed countries. Due to lack of funds and the current financial state of DISCOMs, the DTs are operated beyond their useful lives by repeated inefficient repairing, resulting in a lower efficiency of operation. Efficiency improvement in DT becomes a crucial factor to prevent losses and save DISCOMs from the financial burden of procuring new DTs to meet the current energy demand. Realizing this need, International Copper Association, upon investigating the problem deeper, observed that high failure rates and losses in DTs originating from weak practices in asset life cycle management, specifically from poor maintenance, poor design and workmanship, use of substandard material or aluminium winding, irregular monitoring, and poor repair practice. What we did? Within these findings, we suggested a viable solution which was tried and tested and made operational in the field by improving the repair through winding compensation. The solution was named Active Repair Solution of Legacy Distribution Transformers. Active Repair followed a standard method towards execution of repair. How we did? Active Repair Solution focuses on technical loss reduction in DTs through winding compensation, including any change in winding material. The core, if not beyond a certain level of degradation, is left unchanged as different makes of DTs will require different laminate designs and cuts, and that would not be an easy and replicable repair methodology. What we got? When we tried on 100 kVA and 200 kVA DTs at MSEDCL, an active repair solution proved its mettle in the following attributes. 1. Loss reduction. 2. Improved reliability. 3. kVA capacity enhancement. Post-field installation of active repair DT, a transformer monitoring unit, a TMU, was installed to capture continuous performance of repaired DT. TMU includes energy monitoring unit on LT side and a temperature monitoring unit for transformer. Energy monitoring unit consists of an energy meter connected to the CTs on the LT side. Active repair provides an opportunity for sizable technical loss reduction at reduced costs over the replacement with new DT incurring heavy capex. In addition, the reliability improvement assures of a lesser downtime. It also creates an opportunity for the DT OEM or repairer to become a stakeholder in the network operations and maintenance. It further reduces O&M expenses, thereby improving the financial health of DISCOMs. It is estimated that MSEDCL can save about 215 crore annually by active repair of 100 kVA and 200 kVA DTs, which accounts for 63% of the total MVA capacity. It can be seen from the study that there is significant deviation of no load and full load losses from the specified values in the DTs present in the network. If active repair is implemented, it will lead to a sizable loss reduction and prevent the DISCOM from future losses. DISCOMs can develop new business models and performance-based contracting for DT repairing, including technical loss reduction and possibly some combination of managed services around DTs for effective life cycle asset management. In this way, we can transform the transformer and give a new life to it.